This should not be possible. There's a place in China where planes land on something that shouldn't even exist. And the way it was built breaks everything we thought was possible. In this video, you'll see how an airport was built by removing entire mountains. Not one, but hundreds. A place where no flat ground existed, and everything had to be created from scratch. But what it took to actually make this work is where things start to get extreme. For decades, infrastructure was built around natural limits, flat land, stable terrain, predictable environments. But in regions like Chongqing, those conditions don't exist. The landscape is dominated by steep mountains, deep gorges, and unstable surfaces. Traditional construction doesn't work here, so instead of avoiding these areas, engineers started doing something radically different. They began reshaping the terrain itself, not adapting to nature, but redesigning it. And this project pushed that idea further than ever before, because this isn't just an airport, it's a controlled operation on the edge of physics. The Cliff Airport now. Here's where things get unreal. This is Chongqing Wushan Airport, built at around 1,770 meters above sea level, right on top of a mountain ridge, surrounded by steep cliffs and deep valleys on all sides. From above, it looks like a runway floating in the sky, almost like an aircraft carrier suspended between mountains. But this wasn't a natural plateau. It didn't exist before construction began. The entire surface had to be created from scratch. This means the runway isn't built on the mountain. The mountain itself was engineered to hold it, and the process of creating that foundation is where things start to become extreme. To build this airport, engineers didn't just clear land, they removed entire sections of a mountain. Over 4 years of construction, from 2015 to 2019, more than 9,000 tons of explosives were used. Controlled blasts executed in precise sequences, not to destroy randomly, but to shape the terrain with accuracy. Peaks were cut down, valleys were filled. Millions of cubic meters of earth had to be reshaped to make this possible. Every layer compacted and reinforced. This wasn't construction in the traditional sense. It was large-scale terrain engineering. But even after creating the surface, the biggest challenge hadn't started yet: the real-time operation. Because once the ground existed, everything had to be controlled in real time. Every movement, every machine, and every adjustment had to happen at the exact right moment. Multiple teams operated simultaneously, with heavy equipment that had to align perfectly. Materials were lowered, positioned, and fixed with extreme precision, each step placed exactly where it needed to be. Instructions were constant lowering, adjusting, holding, and realigning, all in a continuous flow. At the same time, a network of sensors tracked every variable, including wind speed, vibration levels, structural stress, and alignment accuracy. Even the smallest deviation was detected immediately, recognized in real time, which means even the smallest deviation was corrected instantly before it could affect anything else. Because at this scale, a small error doesn't stay small, it spreads fast. And this is where the operation became critical. At this altitude, conditions are constantly changing. Wind speeds can increase within minutes. Calm air can turn into strong gusts without warning. Pressure differences affect stability. Even small shifts in pressure can influence how the entire structure responds, and the terrain itself remains unpredictable. During construction, there were moments when conditions pushed the limits. Wind forces exceeded safe limits. Sensor readings became unstable. Load stress increased across key structures. But the operation didn't stop. It kept adapting continuously, in real time. Instead of reacting after problems appeared, the system predicted and adjusted before failure could happen. And that's where things become even more critical. Because even staying stable wasn't enough. That's exactly why this couldn't rely on machines working independently anymore. It was a fully integrated system. Drones scanned the terrain from above in real time, constantly updating the understanding of the environment. At the same time, sensor arrays monitored structural integrity, tracking how every part of the structure responded under pressure. Vehicles transmitted positioning and movement data continuously, ensuring that every action stayed aligned with the overall operation. All of this was connected into a single feedback loop, where information was constantly shared analyzed, and adjusted. Each phase of construction followed a repeating cycle, measuring the current state, adjusting where necessary, stabilizing the structure, and repeating the process again. Calibration wasn't something that happened occasionally. It was constant, happening all the time, every second. This means nothing had to wait for problems to happen. Everything stayed on track from the start. And once everything runs like this, there's no room left for even the smallest mistake, because now everything is under pressure. And that's where all of that precision is put under real pressure. The only way this could work, every structural layer had to be perfectly aligned. Even the smallest deviation could affect everything built on top of it. Every material had to handle long-term stress, not just in ideal conditions, but under constant exposure. Engineers closely monitored how materials responded over time, how loads were distributed, and how environmental conditions affected the structure. Every measurement had to confirm that the system remained stable under pressure, not just for construction, but for long-term stability. Because this airport wouldn't just be built, it would be exposed to wind, to pressure, to constant environmental stress, which means the structure had to remain stable, even when everything around it changed. This means the structure wasn't just designed to stand, it was designed to survive under continuous pressure. But even that wasn't the hardest part, because what this made possible goes far beyond this single project. Mountains can be reshaped, land can be engineered, environments can be controlled. This airport proves that even the most extreme locations can be transformed into functional infrastructure. The site itself was never meant to support something like this. Engineers had to level the top of a mountain at over 1,700 meters above sea level, cutting down peaks and filling surrounding valleys to create a stable surface. Entire sections of terrain were removed, while other areas were reinforced and rebuilt to support long-term structural loads. More than 9,000 tons of explosives were used not to destroy the landscape, but to reshape it with precision. What once was a fragmented mountain ridge became a continuous platform, stable enough to support a 2,600-meter runway. And not just any runway, one that sits surrounded by steep cliffs and deep ravines, giving the appearance of an aircraft carrier suspended in the sky. And when systems like this scale, entire regions become accessible. Remote areas, once isolated by terrain, can suddenly be connected to global infrastructure. Places once considered impossible to build on are no longer out of reach. This means the question is no longer, can it be built, but where do we stop? And that leads to something much bigger, not by simplifying the conditions, but by actively reshaping them. What this project reveals is something different. It shows what happens when construction is no longer limited by geography. This airport wasn't built where conditions were ideal. It was built in a region defined by extreme terrain, high above the Yangtze River, in an area where flat land simply doesn't exist. Instead of finding a place that worked, engineers created one. And that changes the role of infrastructure entirely, because projects like this are no longer about connecting existing locations. They're about making new ones possible in places that were previously unreachable. This airport now serves as a gateway to remote regions, opening access to areas that were once isolated by mountains and deep valleys. And it shows how far control has advanced, not just in building something like this once, but in maintaining it over time in an environment that is constantly shifting. Because when you reshape an entire mountain to make it work, there's no room for anything to go wrong. And when planes land on something that was never there before, you realize how much of the world can still be reshaped.